Hello everybody, welcome to RodLab video tutorial number 8. In this video I'm going to talk a bit about some basic taper translation theory, a little bit about how RodLab calculates taper translation, and do some comparisons to the Garrison method, which number one, because Garrison method is very familiar to a lot of people, and number two, because it's somewhat similar to what we're doing in RodLab. So for starters, I've already got a bend form window up. I've got a couple different bend forms on a Dickerson 8013. First one is with an accel factor of 0. You can see it's an unbent rod straight up and down. Next one with a little bit of acceleration in here to give a bend form. So talking about the Garrison method, first off, Garrison starts with a rod, call it in this position, but an unbent rod, and he calculates what's called a stress curve. It's a characteristic curve for the rod. The way you do that is you take the rod and you assume it's being, say, accelerated to the left. And when you do that, you're going to have forces put on the rod by a number of things: the line at the top, the weight of the rod itself. I forget everything that Garrison uses, but the ferrules, I think the finish mass, the line between the guides, all those things are going to put forces throughout the rod. And if I move through the rod and look at the dimension here, by looking at all the forces up above, those forces are going to create a torque here, or a moment as you would refer to it. And by taking the two, the moment or torque combined with the cross section, you can calculate what stress that would cause at that particular point, and calculating through the whole rod would give you a stress curve. So if I look on hexrod.net, here's my Dickerson 8013, and here's the stress curve for that rod. Now I've already got that copied off over here. So I'm going to look, I've got the stresses for the rod that I've just bent here, the same thing, the 8013. And that first curve where it's unbent, I have no stress because there's no force on that. But the next one, where we do have some bending, you see I've got a stress curve calculated. So pulling that hex rod Garrison stress curve up, it might not be immediately obvious, but these two curves are reversed, and that's because hex rod uses 0 as a tip, and I use 0 as a butt in RodLab. So let's go ahead and swap those over. Let's zoom in a bit, and you can see when I line these up together, there's a lot of similarity between these two curves, right? Now the tip in my curve is a little bit lower on the magnitude scale compared to the Dickerson rod, or the Dickerson stress curve, which uses an unbent curve, but overall the characteristics are very similar. So the idea that you would use for a Dickerson to translate this would be, I would take the stress curve that I generated from this rod here, and I would now make changes to the rod. For example, if I use a different line weight, I would be putting more forces through the rod, and now it would recalculate the rod dimensions that would give me the correct stress curve, or the stress curve that I'd already chosen. And again, similar to a bend form, I'd have to do an iterative structure where I would calculate the bend form, look at how those masses of the different rod dimensions had changed, and then calculate again to try to get back to the stress curve I was aiming for. So there were some issues with this that I found, and the first issue is that bamboo is not a homogeneous material, and Garrison's method treats it as such. So what you would find is, if you're, say, increasing the dimension of a rod to maybe use a higher line weight, you would assume that increasing the dimension some amount would increase the stiffness of the rod, or the stress curve of the rod, the same amount. And the problem is, as you make the dimension bigger, I'm getting more and more of the pith here, right? The overall quality of the bamboo decreases. And that's something that Garrison doesn't directly deal with in a stress curve. And that's not really a hack on Garrison, because if you're looking at what he's doing, we're looking at math that's being done with a slide ruler, and I'm not really sure how you would accommodate changing bamboo structure with a slide ruler in this type of math. It would be probably, maybe not impossible, but it would take way more time than it would be worth it. So Garrison compensated for his larger, longer rods, he actually made a change to his characteristic stress curve. He would lower the stress curve, which would give you a bigger dimension to account for the fact the overall stiffness of the bamboo had dropped, because we're getting more of the pith in the rod. So what we're doing, another factor that I think is a limiting factor in the Garrison method, is stress curve is dependent on the dimension of the rod to the third power. And what I'm really more interested in is the stiffness of a rod, and that's a function of rod dimension to the fourth power. So what we're doing with a stress curve is we're kind of approximating what is a fourth order curve with a third order curve. And if you're not moving far away from the original design, maybe moving a line weight, maybe changing a ferrule location a little bit, or maybe using a different ferrule material, you're going to get a pretty good approximation. But the farther and farther you move away from the original rod, the more and more that third order curve is probably going to suffer in terms of accuracy. So what I'm doing in RodLab is I've got this EI bend curve that I've mentioned before, and let me pull my stress curve up. So this is a Garrison stress curve for the 8013, and this is my EI bend curve. And as you can kind of see, they're somewhat similar in overall shape, but there's some little bit different characteristics here. So what I'm doing with the bend curve is same idea. I'm taking an unbent rod, and I'm calculating the stiffness throughout the whole rod by using a little bit more accurate methods, I would say, or at least a little better approximations that allow me to account for the fact that bamboo is not homogeneous, and account for things like different finishes, and which I think you can actually do with Garrison anyway, but account for different tooling diameters as you're doing hollow rods and that sort of thing. But I calculate a stiffness profile, and then from that I calculate what I would call a bending propensity, for lack of a better word. So same idea, you take an unbent rod, you put all the forces of the rod when you accelerate it, but now instead of using a third order stress curve, I'm going to calculate a fourth order bend curve. And from that I can hopefully get maybe a little more accurate results, maybe not so much close up if I'm making a single line change or something like that, but if I'm going from, say, a solid rod to a hollow rod, in theory this is going to give me better results. So I'm running a little short on time here. I'm going to stop it, and in the next video I'm going to open up the bend form window, or not the bend form, I'm going to open up the taper translation window and show you how to work through that.